Deformation of peat soil reinforcement settlement using single-layer bamboo dendrocalamus as per. As for introduction, peat soil is a type of soil that poses many challenges for geotechnical engineers. It forms from the accumulation and decay of organic matter that comes from plant waste. Peat soil has very extreme properties such as being highly compressible when any load applied on it. The objective of this study is to identify how single-layer bamboo dendrocalamus asper, which is used as a reinforcement for peat, affects the deformation settlement of the soil. For the methodology part, the flowchart below demonstrates how this research was conducted, and the diagram next to it illustrates the lab model settlement box using a sample taken from Kampung Parit Puteri Menangis, Bendut Johor. For physical properties analysis, the specific gravity of the peat soil was 1.23, which within the range of 1.07 to 1.63 for the Johor Hamid peat. The peat soil has high water content of 672% due to its spongy characteristic that allow it to absorb and retain more water. The water content varied from 652.1% to 898.91% among different samples of the peat soil. The peat soil also had a high organic content of 88.34% to 96.19%, which was consistent with the typical organic content of 70% to 98% for peat soil in Malaysia. The organic content in the peat soil was mostly decomposed as indicated by the fiber content of 38.1%. The fiber content placed the peat soil in hamid category, which means that it had a moderate degree of humification. The peat soil also classified as pseudofibrous peat based on its degree of humification. Next, as for mechanical properties, the compression index values for the hamid peat soil in this study were significantly lower than the values reported by Duraisamy et al., which ranged from 1.3 to 2.78. The compression index values obtained from this study varied from 0.13 to 1.54, indicating a lower compressibility of the peat soil. The coefficient of consolidation values for one-dimensional consolidation tests were also lower than the values obtained by Johari et al., which ranged from 0.62 to 4.925, suggesting a slower rate of consolidation of the peat soil. The coefficient of secondary compression values for the hamid peat soil in this study were comparable to the values reported by Duraisamy et al., which ranged from 0.0225 to 0.048. It is reflecting a similar degree of recompression of the peat soil. The graph effect of settlement on the compressibility with single-layer bamboo laminated beam and without bamboo demonstrate in this slide. The graph below indicate the effect of the settlement on the compressibility with a single-layer bamboo laminated beam and without bamboo for 1 hour period time, while the graph next to it display the displacement of single-layer bamboo laminated beam and without bamboo for 2 hours period time. Graph below show the load settlement of displacement for a single-layer bamboo laminated beam and without bamboo for 1 hour and 2 hours period time. Peat soil is a type of organic soil that has sponge-like characteristics which enable it to absorb and retain water. This makes it soft and unstable in its natural state. Therefore, the stability of peat soil needs to be enhanced for long-term purpose. In this study, bamboo dendrocalamus asper was used as a reinforcement material to investigate the displacement of settlement of peat soil. The peat soil samples were collected from Kampung Parit Puteri Menangis, Bendut Johor, and their physical properties were determined as follows: moisture content of 672%, specific gravity of 1.23, organic content of 88.34 to 96.19%, fiber content of 38.1%, and degree of humification is H4 to H6. These physical properties influence the performance of the settlement behavior of the pit soil. The results show that the displacement of settlement of pit soil reinforced with bamboo was lower with a single layer of bamboo than without bamboo. The bamboo reinforcement also reduced the displacement of settlement of pit soil under different load conditions. The performance of pit soil settlement depends on the characteristic of the pit soil, which varied from different locations. This posed different challenge for the design and construction of foundations on those pit soil. That's all. Thank you for your concentration.